In a world where time can be paused. That is your world. Welcome to the video. In today's video, I'm going to be showing you how we can pause time on movable objects. That's right, these objects are movable. This is not pausing a timeline. These are real objects being shot out of an emitter, as we can see here. They're being emitted, meaning they have physics, and the object itself is movable. So we can see that we can pause time by holding a button on our controller, and when we let go, it resumes its course and continues forward. If you're interested in learning how to make this, stick around because I'm going over it right now. Okay, so to get started, let's go ahead and grab a sculpt. It doesn't really matter what it is. And we'll just use this cube for now. So I'm going to stamp a microchip onto this because we're going to have to add a little bit of logic. And the way this is going to work is basically it's going to sense the movement and the rotation of the object. And when we want to pause time, we're going to store those values and then reapply them when we let go of the pause mechanic, so that it can use those values to resume its movement. This means we're going to need to take these values. So here I'm going to take the movement values, so the X, Y, and Z of our movement, and I'll place them into a combiner. Cool. And I'll need to get another combiner out for our orientation. So this is going to be a rotation, excuse me. And now, the way these work is it has rotation around each axis. And this rotation combiner is a little bit confusing because they're a little bit out of order. So our X rotation, you can see this, is actually our pitch, which is the middle one. So it's not straightforward like this one. The Y rotation is the yaw, meaning this type of movement. And so Y goes into the yaw. And our Z orientation is our roll, so that goes in the bottom. So we can take both of those and place them into a transform. So we have our position and our orientation, and we can place that into a signal manipulator. The reason we're using a signal manipulator is because it has this freeze. So if we were to ever pause time, we'd be able to freeze this value, whatever the values are, and then when we want to let go of time pausing, we can reapply these values and then unfreeze. I'm going to go ahead and get out a separate microchip, and we'll just put a controller sensor in here, and we'll put this on remote controllable. And I'll get out a variable, and we can call this, I don't know, time or pause or something like that. I'll call it pause time. That works. And so whenever we press this X button, we'll set this pause time. And we'll actually leave it continuously while powered. So it'll always be 0, and when we hold X, the value will be 1, and when we let go, it'll be at 0. Cool. Now you can use, you don't have to use a variable if you don't want to. You could use something like a wireless receiver and a wireless transmitter, but this has no frame delay, so you know, it's up to you whether or not you want it, and maybe I can discuss a little bit of advantages and disadvantages around that as well. So let's go ahead and get out a variable modifier, and this will get that value, and that will go into the freeze output. So whenever we pause time, that will freeze the value in here, and then when we let go, it will unfreeze it. Now we're going to want something else there, but for now let's go ahead and discuss what we're going to do with these. So what we can do is we'll get out some splitters, and we'll get out a advanced mover, and we'll get out an advanced rotator as well. Okay, So all of these we're actually going to want to set. Well, we can use override, or we can set all of these to 1. That way we can have these, what do they call this? Modulate, multiply. Okay. So we can do something like that. And we can do the same thing here. For these, I'll go ahead and just, instead of modulating, I'll do it the other way. So like we said before, remember, the pitch is the X, so pitch goes here. The yaw is the Y, and the roll is the Z. And I'll just set those to overwrite like that. Okay, so that's good. But we want this object, obviously, to be movable, right? So that way it can move. Now, the problem right now is that these are on, and they're receiving values of 0, so it's frozen in place. So these shouldn't be on unless we let go of the pause, and we only want them to be on for 1 frame. So what I'll do is I'll get out a signal manipulator, and we can just pulse this when this is off, and that can turn these things on. So what I'll do is I'll just pop all of this into a microchip here, like so. And so when this thing pulses, it'll turn that on. So in order to get it to stop moving, when it is paused, we'll go ahead and go into here and we'll turn movable off. Right? So when it's pausing, this keyframe will turn on, and so it stops moving. Now, one issue here is that when I let go, it turns those on. However, these values are lost because when we let go, these values are no longer frozen, and they'll pick up the wrong values. We can see this a little clearer if I put this whole thing into an emitter. So I'll put this thing in here like that. Okay. And now we can see I'll pause time, but when I let go, it stops dead and just falls, right? So it obviously isn't carrying those values. So one way we can deal with that is that this will continue, this 1 frame delay will still pause this value. So when I let go, it can resume the, well, close to the trajectory it had before we had paused. And that's because we're holding on to those values for just 1 more frame while these are on. When time is paused, we obviously don't want this thing to keep emitting at the same rate, because we'll have things like this, right? If you had like a cannon or something, you wouldn't want that to happen like that. So let's talk about how we could deal with that. So let's say we have an emitter. You can play with the time between emits if it's continuous. Another thing you could do is you could have this on once, and you would have, you know, like a timer or a timeline, and using that value, we'll get the pause time, we'll get it. Using that value, we can mess with this timer a little bit. So let's think about how we can do this. We can put this on speed, for example, and since the pause time goes from 0 to 1, we'd want to invert that. Oops, let's put that in there. We'll invert it so that it's at 1 when nothing's happening. We'll put that into the playhead, and that way when we pause, the timer itself pauses as well. So let's go ahead and set this to like 0.5 seconds. So it's going to launch one every 0.5 seconds if I manage to hook this up correctly. So every 0.5 seconds it'll do that, but when I hold X, the timer pauses, and so does the emission. And it picks up right where it lets off, or where it left off, right? The reason you would want to use this instead of messing with this time between emits is because if this was like 20 seconds and then you shortened it down to 1 second, then when you let go and it goes back to 20 seconds, you have no idea where the internal timer is. I don't know if it resets. I'm not really sure. This just seems like a safer bet. So you could use a timer like this to control your emissions there. Now let's go ahead and give this thing some rotation so that we can see that that's working as well. So now we can see it's coming out, it's rotating, and it continues to rotate afterwards, which is really cool. Mess with the rotation a little bit here, just to make it even wonkier. Right? Now, let's talk about drawbacks here. What this system can't do. This is different than a traditional, game engine. In a normal game engine, you could just you can do physics updates based on the amount of time since the last update. And so it's really easy to mess with time in other game engines. In Dreams, we don't have real control over that. So you couldn't necessarily very easily do like a slow-mo kind of effect. You can, but it's going to be a lot of extra gadgets and math, and it might be kind of heavy. It's not going to work the best. The other issue here is that if you spam this, obviously this thing doesn't have enough time to really pick up on the subtle changes between each pausing, right? And so we can see sometimes one of these things kind of just falls flat because maybe it collided with something else. But if we keep if you keep pausing it, it's gonna act weirdly. Also, if you pause it like right after this thing comes out, sometimes you'll see that it just drops because there's just not enough time for this thing to catch any information. Also, right as soon as it comes out, we turn off moving or movable, and so that probably just stops it dead in its tracks. And that way it doesn't have any data to return to when we unpause. So there's something to keep in mind there. So that's how you can pause actual movable objects in real time and resume all that stuff. If you wanted to really sell the effect, you'd probably want to use like a grade and effects gadget, and we'll just get a keyframe out. What we'll do is we'll turn the contrast all the way down, bring the saturation down, and we can make it kind of more grayscale. And I guess you could add other effects, scan lines or something. And that would be turned on whenever the pause time is on, so that way you see these things flying, and then when you pause, everything kind of goes gray. So, like I said, it's not perfect. You're going to have things if you allow the time to continually pause, but you could always add a cooldown onto that. There are plenty of videos on how to do a cooldown mechanic, so if you don't know how to do it, you can ask a comment, and I'd be happy to explain or point you to a tutorial that shows how to do it. I may even have one. I don't even remember at this point. But I know for sure Tap Giles does, so I'm sure you could find one on his channel. Anyways, there it is. I hope this was helpful and interesting. If you enjoyed this video, please let me know. I would love to hear about that. I hope everyone is doing well and staying safe. I'll see you next time.